You're all here to hear what's new in Axon 3. And at school, I was always a horrible student, especially in history. I was always wondering, what's history for anyway? I mean, you talk about things that have been long gone, it's all past. You can't change anything about it anyway, so what's the point? That's a common question at that age, anyway. And they told me, yeah, but to understand the future and to be prepared for the future, you need to understand the past. So I thought, hey, that's good. Good for this presentation. Because we're going to talk about what's coming in the future and what's here right now, actually. So I thought I'd start with a little history. So let's go back to 382 BC, which is pretty far in the past. Now, honestly, the whole history, I didn't really like it, and I'm not going to bother you with it either. This is Philip of Macedonia, who invented the divide and conquer principle. It's pretty useful, but if you want to know more, just read it for yourself. Let's skip to 2009, because that's when the interesting history actually begins. I quite often get the question, how did you invent Axon? How did you get the idea to build something like Axon? And the short answer is I didn't. It just happened. It was an accident. What I was doing, I was working on a project. I was applying domain-driven design. So I had read the big blue book by Eric Evans, and I crawled my way from cover to cover. It's a pretty intense read. And I decided to apply that to a project, and that helped very well. It helped keep the complexity at bay. Right? It was a project I was working on. It was a pretty small project, but there was a lot of little intricate, complex little things. So we applied it, and we noticed that it worked very well. And then came sprint number, I don't know how many, and we had to create some management reports, or at least different views on data. And then things again became complex. So I was really happy with that complexity that was minimized, but still, even in that little project, things got more complex than I thought they need to be. So that made me investigate something that was coming up at that time called distributed domain-driven design. And basically that was an idea from Greg Young, and he said, well, the problem is you don't have a single model, you have multiple models. For the reads and the writes, you have to use different models. And then in the end, it was more about reads and writes than actually domain-driven design. So the distributed domain-driven design was then called CQRS later on. So I was experimenting a bit with an event-driven architecture and event sourcing and writing some code to give it a try. How would that work when you do something like that? And that's when I noticed that in my little pet project that I had in mind, I don't even exactly know what it was about because it was never built. I had spent a number of days writing code, and none of the lines of code had anything to do with the use case that I had in mind. So I thought, hey, if I need to build this to get this working, everybody needs to do it. So yeah, let's create a different Maven module for it. And it was on Google Code anyway, so I thought if the world can see it, they can tell me I'm doing something really stupid, and at least get some feedback on it. And before you know it, the framework is born. This is the Git log. I had to navigate quite a few pages to actually get here. This is the initial commit on January 19th in 2010. Unfortunately, that is not the absolute first Axon commit. The first Axon commit that wasn't actually called Axon in the beginning was a little bit before that. But this is the birth of Axon. Then in 2010, something weird happened. I got an email from a company in France saying, "Hey, we're using your framework in production, and we thought you'd like to know." So yeah, that's pretty cool. So I thought they must be doing something small and unimportant. So what are you using it for? It's a medical system. Oh, okay. And what happens if it fails? I mean, it's it's 0.4, right? It's not production grade. Yeah, we know, but we've tested thoroughly and it works. So okay, I just assumed that. It's a company in France that tracks the tools used for dental implants. And these tools have to go through a cleaning process, and everything has to be audited, and when are the tools used, and who cleaned them, etc., etc. So if you go to France and you have some problem with your teeth, you might end up becoming a few events in an Axon event store. Probably still based on Axon 0.4. When Axon 2 was out, actually I told them, Axon 2 is out. They said, oh no, we're still on 0.4 and it works fine. So, okay. Please don't change it if it works. And it's only in November that actually we were confident enough to use it in projects. We didn't tell the people that gave us this project that we were going to do that. No, it's not entirely true. Actually, it's the first project that we applied it in are Bridgebig and Aggregate Modeling. And Aggregate Modeling will give you a presentation about what has happened. I was involved in the start of the project, but I haven't been involved for 3 years now, I think. So we'll see what's happened since then. And Bridgebig, actually, the CTO of Bridgebig is now the main developer of Axon 3. That's René over there. So he's involved in Axon now as well. So we move on to 2011, and that's when the Axon 1 release was made. We had a feeling, now we've got something that can be properly used in production. Or maybe it had to be used in production, so we call it 1.0. I can't remember exactly what the political aspects of at the time were. And what Axon 1 provided were some basic infrastructure components that we still have in Axon 3. Like the simple event bus, simple command bus, things like that. And we had annotation-based event sourcing. So that made the whole process of event sourcing just slightly easier. But there were some pitfalls or some downsides as well. And one of them is that the events at the time, so who here has experience with Axon 1? About 6 for you. So at the time when you created an event had to extend an Axon class. Right? That was horrible. So that was one of the lessons learned. The other thing is that the event store, Axon needed a lot of contextual information, and that was actually stored in the same blob as the rest of the event. So creating upcasters was pretty difficult because you had to make sure that you copy over all of the Axon stuff as well, and then convert your own stuff. That was nasty. For those who didn't raise their hand, just imagine how nasty that must be. And the other thing is that there in the event itself, there was no distinction between the actual payload or the actual event and just some metadata that describes the context in which the event occurred. It wasn't all there. None of it was there. So that gave us some ideas to build Axon 2. That was quite a lot of work. It took about a year. And in 2013, we released Axon 2 in January. And of course, January was way too cold for an event, for a launch party, so we organized that in end of February, beginning March. And of course, we forgot, I just created the release, and I thought, hey, maybe we need to celebrate. That party was slightly smaller than this one. There was less people. And the big difference there was the message API. So now the event is just a message, and you provide your whatever you think is the event as the payload of that message, and you have the possibility to attach metadata, and of course the event store stores all that metadata separately from your payload. So now your upcasters are just working on your own code. So if your upcaster is difficult, it's really your problem, not mine. But another big difference is the scalability. So in Axon 2, we created some components that allowed the application to scale. Actually, BridgeBig was one of the bigger sponsors of that code, and because I told René quite often, Axon allows you to scale. You know, if you need to scale, you can. I told him all the time. He said, "Well, prove it." Okay. So I changed some configuration. Didn't change any of the logic of the application. Just some Spring XML configuration. And I told him, you know, here's a jar. Run it on your machine. It will scale. And he ran the jar, and guess what? Didn't work. I had to open up some firewalls on my machine, and then it worked. But so that was pretty cool. But there's again some downsides, and of course now I can mention them now that Axon 3 is coming. So who's still developing on Axon 2 these days? Well, that's almost everybody. That's a good sign. But there's still this hierarchy that we had in events in Axon 1 is in Axon 2 still there, but in the aggregates and in the sagas. And I got a lot of remarks of people saying, well, can't you remove that? And yeah, I probably can, but I need to figure out how. And that was pretty difficult. Fortunately, the progress in Java land helped us a little bit, and especially Java 8 made it a lot simpler to not only make it work, but also make it work in a usable way. Yeah, and then there's this little island in the Mediterranean where some of the people had to do some massive replays. They're going to tell you more about it later on. If you have an event store with billions of events, it might take a while to do a replay. So every little inefficiency that's in there will cause a massive increase in the total processing time. And that's something we had a look at as well. And also based on their experience, we've changed the way that replays work in Axon 3, and I'll get into that later. And the last one is the infrastructure complexity. There's quite a lot of components that you need to configure, and especially as soon as you start scaling out, it becomes more complex. There's a lot of components that you need to configure correctly. That's also something that Axon 3 will make easier. And the future plans that we have for Axon 3.x will make it even simpler. So, moving on to 2015. That's actually when the very first commit for Axon 3 happened. And I do remember that the Aggregate team was working on Axon 1 for quite a long time. And exactly the day when they said, well, we finally had Aggregate converted to Axon 2. That was the day after I did the first commit on Axon 3. I was a bit reluctant to tell you, but I don't know where you are right now. Oh, he's in the back. That's safe. So they probably have another migration coming up soon as I start with Axon 4. So what we wanted to do is provide better APIs. To simplify that infrastructure, but more importantly to make sure that you have more modeling freedom. Right? The domain model is a very important aspect of your application, and we want Axon to be the least possible in your way of defining the model that you need for your application. And of course we want the replays to be easy and, more important, fast. So they have to be in an optimizable way, at least, so you can tweak whatever you need to tweak to make them work. And that brings us to 2016, and that's right here, right now. So the Axon 3 version is available for, we call it public testing. So we want to get your feedback. We want to hear from you what you think of the changes in Axon 3. We didn't call it 3.0 final yet because well, we want to incorporate any feedback that we get. There's always these little edge cases where we need to tweak a few things, and we don't think that our team is, per definition, the best to do everything. So that's probably you guys that need to implement it somewhere and solve the real business problem that you're working on. So please provide us with your feedback. So why Axon 3? Why not just Axon 2.5 and put some improvements in there? First of all, we got a massive amount of feedback from the community in the last year, actually, and even before that. The Axon community is growing pretty fast. So in the Axon 1, well, there was no launch party. It was probably a lunch party. Axon 2 was already slightly bigger. I think it was about half of what we have in the room now. So who knows what's coming up? But we see in the number of downloads they increase pretty massively. So we get a tremendous amount of feedback from there, and we wanted to be able to incorporate all of that feedback without any restraints. And when you move from a version 2.4 to 2.5, there's a number of API constraints that you have to be able to do that. The second motivation was that the application ecosystem is pretty, well, it's evolving pretty fast. Back in the days, enterprise application servers were normal. Nowadays, you're either stuck with them because somebody else bought the licenses and they don't really know what the good aspects of software development are. But nowadays it's all about microservices, lightweight little services that we want to spin up and deploy every 5 minutes if we want to. Right? If there's a change, why not deploy it? So there's a lot of change in that area. And of course the whole monolith versus microservices as well is that we don't want to be building a huge single application. We want to build these small deployable units. And the last one is, of course, well, we needed to make these major API changes, and that's why we decided let's go for 3. There's a migration involved in moving to Axon 3. We'll just have to apologize for all the time spent on moving. It will be slightly simpler than moving from Axon 1 to Axon 2. I promise you that. So that's where Axon 3 comes in. So I want to go a bit into detail on what's changed, and well, the most important thing is Java 8. So Axon 2 works with Java 6+. Axon 3 requires Java 8+. Of course, Java finally came with a time API that is usable. We don't need to do weird stuff with calendars or even worse, the mutable date object in Java. So we had the ability to kick out Joda time, that's the dependency removed. And of course there's all these functional interfaces and lambda expressions now that you can use in Axon, in Java that are very usable for Axon as well. There's a lot of places where we now expect a functional interface instead of whatever interface that we had previously. So you can use lambdas almost everywhere. And the last one is streams. There's also a lot of streams in Axon, event streams, command streams, anything. So we want to use the Java Stream API for that as much as we can as well. And in places where we can't, we at least have the possibility to create a stream out of that interface that we provide. And there's another realization that we made in Axon 2. A lot of the stuff is about command handling, and events, and especially the whole query model part, is sort of oh yeah, it's also there. Of course, there was the event bus and the event handlers, but we realized that first and foremost, Axon is a messaging framework. And the whole CQRS aspect is a very nice implementation detail, and it's a detail that gives us a lot of power and a lot of flexibility. But without the messaging, I don't think Axon would exist. I mean, if you remove the messaging from Axon, probably what you have left is a few utility classes to convert an object into something else. So we did a very big refactoring of the unit of work, and that is probably a component that you probably don't have to deal with. Hopefully you didn't have to deal with, because it wasn't very easy to use. I see some people nodding, yeah, I did have to use it, sorry. But Right now, what we've done in Axon 3 is the unit of work is just the processing. It's the context that describes the processing of a single message. And it doesn't matter whether that is a command message or an event message, or later on, maybe a query message. So we removed the distinction between commands and events. And it's also the life cycle. The unit of work takes care of the life cycle of processing an event. So of course there's the processing itself, and then you want to publish all the side effects that that the handling has. And it's a lot easier now with the new unit of work interface to just register a lifecycle handler. What we've also done is the correlation data. So it's a lot easier now to pass data from one message to another. In Axon 2, it was pretty easy on the command side. If you had a saga or some event handlers, you had to figure it out for yourself. You had to get the metadata from the original message and attach that metadata to any outgoing messages. All of that is now automatic. So all you need to do is raise an event, and if you have correlation data in the incoming message, they will be automatically copied to the outgoing message as well. That was, I think, the biggest change of all in Axon, at least in terms of how much work it was to get it working. We got it working yesterday night at 3 a.m. Or no, actually it was this morning at 3 a.m. Something like that. But the role of the event store has changed in Axon 3. More importantly, the event bus disappears as soon as you have event sourcing. So basically, the event store replaces the event bus if you use event sourcing. And probably most of you are familiar with this diagram. You have to look very carefully because you're going to miss it as soon as I click. But the major change is this. So, being an architect, I really don't understand what's so hard about all this. It was pretty hard to get the arrow right? But in terms of implementation, this means a lot. So instead of having a command bus and an event bus, we now just have the event bus, and we have our event handling components read from the event store directly. It's actually a very common pattern in some other areas, so we're quite late on adopting this one. But we're happy we got it working, and it gives us a lot of flexibility, especially when it comes to distributing events. Because the event store is a component that is available to all of the nodes, usually. So just append an event there, and some other component somewhere else can read it from there. And one of the problems it solves is the issue of what happens when I store an event, but when publication fails and my system crashes. Well, usually when you have a system crash, you have a problem anyway. But this just adds more problems to the problem, making it slightly harder. So by removing the event bus, that's all gone as well. I mean, it's either in the event store or it's not. It's not halfway in there. And then event consumers just tail the event store. They just tail whatever has been appended to it. Sounds very simple in implementation. It was pretty hard to guarantee that, but it works. A new concept, or at least not really a new concept, but something new in Axon 3 is the event processors. And the event processor is a replacement for what in Axon 2 was called a cluster, or an event listener cluster. Just out of curiosity, who here has ever worked with clusters in Axon? These event listener clusters? No. So there was a lot of people that have worked with Axon 2. You didn't raise your hand. Probably you have worked with them, but just didn't know it. Because in Axon, there was sort of a hidden feature that you only needed to use in specific cases. And when you had to use them, they were not extremely user-friendly. And that's because in 2.0, there were no clusters. They were only added in 2.3, maybe 2.2. And only for one of the implementations of the event bus. Right now, the event processor is what we call a first-level citizen. It is a main component. It's basically the technical component that handles the events. So it's responsible for tracking progress, for error handling, for just making sure it gets done. And of course, it's still the same as in Axon 2. Whatever needs to be done based on the event, that's something you need to develop. And that's a component you want to register with that event processor. There's two types of event processors. One is the old school way, which is the subscribing event processor. You can just subscribe it to the event bus, and it will get a message when it arrives. But there's a new one, which is better, which will be the default if you don't choose any options, which is the streaming event processor. Basically, you give that a stream of events, and on its own, at its own pace, it will process these events. So that will always work when you use the event store. If you use an event bus that has some memory, it will work there as well, very nicely. And these streaming event processors, they store their progress by keeping track of a token. I don't know if you're familiar with Kafka. It's a very similar process. You read from a stream, and every message in that stream carries a token. And when you lose your connection, for whatever reason, you can use that token to continue on where you left off. And that's a very safe way to do it. So the client itself, it knows when it has processed the message. And it can store that token maybe in a database in the same transaction as the changes. So you have guaranteed once processing of your events. Now something else that has bothered us for quite a while, at least in the later days, Spring has been moving away from XML in the last days. I mean, there's a lot of things happening in Spring, and all the documentation, they provide you examples in how to do things in Java config. And oh, by the way, it's also possible in XML this way. That was slightly different when Axon 2 started, so we had a lot of XML support. But nowadays there's also a lot of XML, well, it's fear or disgust or whatever. I mean, we program Java, not XML. Okay, that's fine. But in Axon it's more powerful if you use XML. Some people were okay with that, some weren't. It was possible to do it in Java config, but it was pretty difficult to get some of the configuration right. So that's something we have been working on. This is one of the remarks I got after a presentation at QCon. So there's always this, when you have a presentation, you always have this, what do you want someone to remember when he leaves the room? Well, it wasn't this. So that was another reason for us to drop the XML support. Another big change, especially, it's not so big in terms of the change itself, but the impact it has is pretty intense. And in Axon 2, to create an aggregate, you had to extend the abstract annotated aggregate root. That is not always a problem. I mean, you just put a few words behind it and things work, right? But it was a problem if your aggregate needed to extend some other class for whatever reason that you did not want to be an annotated aggregate root. And it happened a few times. But more importantly, I think it's pretty ugly for a framework to get into your domain. It's already bad enough. I mean, Axon will still be in there, but in a much more decoupled way. And of course, that apply method to apply the changes from the aggregate, it was in the annotated aggregate root class. In Axon 3, it looks quite different. You have your class, and it doesn't need to extend anything. You still have the apply method that you can use, and you can do a static import of the aggregate lifecycle class. And then you can still use the apply method, and Axon will figure out on what you need to apply something. it will figure out what is the aggregate root, what are the entities below, etc., etc. So this gives you more freedom for modeling. And in some cases, well, it was already possible in Axon 2, you have your annotated aggregate root, and then you have your own entity. And that entity had to implement or extend the annotated entity. And to make it really complete, you had to put some annotations on that entity to tell Axon, well, I want my events to be forwarded to my entity, but also some of the commands. Well, if you have annotation fear, and some of us have that, we're always afraid to create classes that have more lines of annotations than actual lines of code. It's not really nice to have to write a few annotations. And things got worse as soon as you didn't have a single entity in there, but a list or a map. And in that case, you had to configure a lot of properties there. You had to use the different annotations. A different annotation for the command handling member collection. So that was, well, nasty in hindsight. And Axon 3, we've changed that. There's just one annotation, aggregate member. So basically you're saying the field here is a member of my aggregate. And Axon will know, okay, I need to forward my commands and events where applicable to that instance. But that's still in the case where you had a single entity. That was the easy case. The difficult case doesn't change anything. It's still an aggregate member. And all you need to do now on the entity is provide some identifier. And that allows Axon to figure out to which of the items in that list the command should be forwarded. And if you just stick to defaults, then it works like this. You don't need to configure anything. So it's convention over configuration. So if there is a get my entity ID in this case on the command, Axon will know exactly how to route it. If the property is named differently, you either rename it or provide the name in the annotation. One of the features that was actually implemented, well, by accident is a big word. It wasn't that of it didn't just happen, but we needed this for ourselves. We needed this to be able to throw away, well, I think hundreds of lines of code simply by supporting meta annotations. So what you can do is you can create your own annotation, and if you're familiar with Spring, it's something that Spring uses a lot as well. You can create your own annotation and then put the Axon annotation on that, and Axon will pick it up automatically. Not extremely useful in this case because it replaces one annotation with another. But it is useful if you want to use what we call handler enhancers. And you could create, for example, an annotation that defines a secured command handler that has some extra behavior on it because you want to do some validation, some authorization. So you can annotate that with command handler, and Axon will pick it up as a command handler, and you can provide a definition saying, well, I want to add extra logic to that handler. And you can do your validation in there. You can get the security context either out of the incoming message or out of anywhere else to find out if you want to invoke the handler or not. And this is something we just needed internally, but we figured out that there's a lot of cases in Axon 2 consultancy that we did where this would have helped tremendously. So I'm pretty sure some of you will find a good use case for it. And something else that we realized, Axon is about messaging. And whenever you have messaging, and especially when you have distributed messaging, there's a lot of opportunity for monitoring and metrics. So Axon is actually in the place where things happen. So it's in between the infrastructure and your application. So there's a lot of possibilities here for Axon to do monitoring. So in Axon 3 we now have the main components like the event bus, event processors. They expose, or at least they provide an API to expose metrics. And we also have an implementation that exposes those metrics using metrics by Job Wizard. So you now have information about processing time. So how long did command processing take? Success to failure rates. So how many events or commands did we process? How many failed? How many succeeded? Of course, the failure should be 0, but that's not always in our hands to make that work. And the last one is a pretty interesting one, is the capacity of a component. So it's the amount of time the component is processing a message versus total elapsed time. That is at least an indication to how congested the component is. Upcasters. Who has had to build an upcaster? It's a good show of hands. Who has built an application in Axon but never had to build an upcaster? Was that either because you left very soon in the project? You saw an upcaster coming up at the horizon, you thought, I'm going to the neighbors, to another Axon project. It's not the best thing there is, although they don't have to be extremely difficult, but there were some edge cases, especially at one of the projects that I was involved in as well. We had to upcast multiple events to a single one. That was a very nice challenge, and we got it done, but that's all I want to say about it. So that made us think about the whole API. I mean, it was a nice API, but there was plenty of room for improvement. So, first of all, upcasting is no longer limited to events. There were a lot of cases where you had these old sagas that we had stored, we want to convert them. And it's pretty easy to convert, but now we had to create our own serializer and do some magic, and now you can just use the Upcast API for that as well. And then there was a problem of contextual information. So you want to know just slightly more about the event that you're upcasting. You want to know what was the aggregate identifier, what was the metadata that was involved. Maybe even upcast the metadata. That wasn't possible either. That was all missing. So that's been fixed. Now you get all the information about the context of an event to upcast it. You can even upcast the metadata if you want to. In Axon 2, there were two ways of doing upcasting. You had the lazy upcaster chain and the eager upcaster chain. So it was either always lazy or always eager. And what we needed was always lazy, except in this one case where we need to store some state in our upcaster. And storing state was a painful process. That's all been changed. We have support for stateful upcasters, and by default they're all lazy. But if you want to make them eager, you can just eagerly make an invocation, just get whatever intermediate representation that you needed. And if it's not been upcast already, it will be done at that point. So it's really easy now to make that everything lazy except for that single instance where it doesn't need to be. And upcasting now has a reactive API, so it's some of the people really like that, and in some cases it's extremely valuable to use the reactive approach, the streaming approach with functions instead of the old school approach. Here's an object, upcast it now, or it will be gone forever. So this describes more or less what's in Axon 3 right now. And it might not be just enough, so we have more plans. So moving on, what we want to do is build the annotation-based message interceptors. So there's a lot of cases where, based on a command, you'll want to do some processing, maybe some validation based on information from a query model. And you don't want to do that in the aggregate because you are locking the aggregate at that point. So you want to do it before accessing the aggregate itself. But in the future, in the near future, you can use an annotation-based interceptor for that. It will work exactly the same way as all the handlers do. It's just a different annotation that you need to use. The same for upcasters. It would be nice if you can just create a method, annotate it with upcaster, and it will get invoked when a message needs to be upcast. In sagas, there's a way of scheduling events, and although that works, it publishes that event to the event bus. And if you have a distributed event bus, the whole application gets the deadline. And in 99 out of 100 cases that I've seen, the saga is the only object interested in that event. So we want to create a deadline API that is easier to use, but also much more local to the actual saga that's interested in that deadline. Conflict resolution is also something that we want to simplify. Who has used conflict resolution in Axon 2? Exactly, that's why. It's actually a pretty simple concept. It doesn't have to be hard to implement, but it was. So we were looking for ways not to need that way of conflict resolution. We have finally got the designs right for a way of doing that in the aggregate itself, making it a lot easier to detect conflicts, where a conflict is a change made by another user that the user submitting the current command may not have seen. Well, the distributed command bus, that's something that we're still working on. The JGroups version kind of works if you tweak JGroups. But if you're on a network that is not extremely reliable, then you might have some jitter effects on the members that leave and come back, and then get a lot of cache misses in the meantime. So we're looking at easier ways and more flexible ways to distribute commands. Most of you probably know Spring Boot. You create a single annotation, you say this is my application, and it will wire everything for you, hopefully the way you want it, and if it's not, well, you just tweak a few of the implementations yourself. That's exactly what we want to do with Axon 3 as well. We have some proof of concept working, but of course it didn't make it in this release because it's only a proof of concept. But it won't take long for that to arrive as well. And in some of the projects we have abused the command bus as a query bus, and that has also led us to believe that hey, there's an opportunity for Axon to actually help on the query side. So there's a number of things that a query bus can do. You can query a component one-on-one, but you can also do a one-to-many type query when you say, I need some information, and every component that believes it can answer that question will provide an answer. And it's then up to the client to decide which answer suits best, or maybe merge them if you want to. So those are some things that we're looking into building for Axon 3 as well. And of course we value your input, so if you think that's total nonsense or you got it wrong, it has to do this as well, please tell us now when we're still working on it instead of when it's released. But there's even more than that. And that's behind the scenes. We're also working on what we call Axon Platform. And Axon Framework is the place where developers, they code their application. They use Axon Framework. But then it goes into deployment, and Axon is, well, it's running there, but there's nothing there. Nothing visible, except for the metrics, fortunately now. But Axon Platform is a sort of an agent server model where every Axon application, Axon-based application, will carry an agent. And that agent will send the monitoring information to a central server. And on that central server, you can also configure certain events to be traced. So you can figure out what the exact latencies are between certain components. So you know exactly how far behind is my query store, and is that still within my SLA boundaries. You can also inject what we call contrast fluid. So it's a medical. If you create an MRI, they can ingest a certain fluid in your veins, and then they can track the flow of blood in your veins. Well, actually, in Axon Platform, you'll be able to do exactly the same. So, based on certain parameters, inject a header into a message, and when a component reads that message, it will report that it has received it. So you can trace the cause and effect of a single message throughout the entire system. It will also allow you to do auto-configuration, so you don't need to configure an instance completely. You don't need to configure all the scalability parameters or distribution parameters in every instance. You just need to provide the agent, and the agent will go to the server and make sure it configures the right implementation for the event bus or a command event store or even the command bus. It will automatically configure it based on what other nodes are there. And the last component that will be part of Axon Platform is an event store that has been optimized for high performance. So the event stores that we support now are all database based. And the problem with the database, it's general purpose. It has create, read, update, delete. Well, we use create in the event store. We use read. We never use update, and we never use delete. When we read the data, we read it in two ways. Either we read from the beginning till the end, or we read from the beginning of a certain aggregate. We want to read all the events of that single aggregate. A database has indexes that allow us to read anything at any time. So there's a lot of ways to optimize a data store for exactly these purposes. We've done a proof of concept with that as well, and it looks very promising. And of course, that's not enough. There are some other things that we are also working on. But this is besides the Axon Framework. And especially in the last half year, a little more than half year, we've been providing a lot of support. So we did some consultancy in the past. I mean, I've been to the Kazumo guys for a few days, and I think most of you, I've met you somewhere at some consultancy assignment. But it's something that we noticed that can add a lot of value. There's a lot of tweaking that we know is possible based on certain parameters that we've seen in other places that might benefit you. And of course, the effects of a wrong choice of model are pretty big. So those are the things that we can help with. And there's a training that I would like to notify you of. There's a training in Amsterdam in July 18 and 19. So if you're looking for another excuse, if you're from abroad, looking for another excuse to pay a visit to Amsterdam, July is probably good weather. All the terraces and bars are all open, so make sure to attend.
Axon 2, I thought.
Sorry.
The training is Axon 2.
Axon 2 and 3 as well, yeah. So depending on what you need. Of course, most of the concepts are exactly the same. It's just some Java configuration that's different. So some coding that's different. So. Yeah, and there's a few people I want to thank, because fortunately I didn't do this all by myself. On GitHub might suggest something different if you look at the number of lines of code. But if you look at the last few months, I think at least René has done far more than I have. But there's a number of people that have been working to make this possible. Many late hours, I think 3 a.m. Last night even, to make sure that things work the way they should. So thank you René, Steven, Marijn, Koen, Joris, and all the other committers that I'm not going to mention all of them. There's about 40 people, more than those that have committed to Axon, so committed code. And there's probably hundreds of people behind the scenes that have done suggestions and remarks based on certain components that we had built. So Thank you. And that's it. So please enjoy Axon 3, and if you have any feedback, let me know.